It is June 1816 in the state of Connecticut, and snow is falling. Not a light dusting, not a freak flurry that melts before it touches the ground, but a thick, relentless blanket of white descending on fields that should be golden with wheat. Farmers stand in their doorways, silent, watching the impossible. Livestock huddle together. Children press their faces to frosted windows in the middle of what should be the warmest month of the year. No one in Connecticut knows why this is happening. No one in Vermont, where frost has killed the corn, knows either. No one in London, where gray skies have not broken in weeks, can explain the endless cold. No one in Geneva, where a young woman named Mary Shelley sits trapped indoors by unrelenting rain, understands that the answer lies on the other side of the planet, on a remote island in the Indonesian archipelago, where 14 months earlier, a mountain tore itself apart. We travel to Sumbawa, an island in the Lesser Sunda chain of present-day Indonesia. Today, Mount Tambora rises to about 2,150 meters. But before April 1815, it stood considerably taller, perhaps 4,300 meters, one of the highest peaks in the archipelago. The people of Sumbawa, the kingdoms of Tambora and Sanggar, lived in the mountain's shadow for centuries. They cultivated rice, traded sandalwood and horses with neighboring islands, and spoke languages found nowhere else on Earth. They knew the mountain rumbled from time to time. Every volcano in the region did. But nothing in their collective memory, nothing in anyone's collective memory, could have prepared them for what began on the evening of April 5, 1815. The first explosions were heard over 200 kilometers away. The British garrison on Java, led by Lieutenant Governor Sir Thomas Stamford Raffles, initially believed the sounds were cannon fire from a distant naval engagement. Ships were dispatched to search for a battle that did not exist. On the island of Sulawesi, commanders mobilized troops against a phantom enemy. The sound of Tambora announcing its awakening was so vast, so unprecedented, that the human mind defaulted to the only frame of reference it had: war. But this was not war. This was something far larger. For 5 days, Tambora continued to build pressure. Minor eruptions sent columns of ash into the sky. Darkness crept over Sumbawa in waves. Then, on the evening of April 10, 1815, the mountain unleashed its full fury. The eruption column punched through the troposphere and into the stratosphere, reaching an estimated height of 43 kilometers. The sound was heard nearly 2,600 kilometers away, on Sumatra. Pyroclastic flows, superheated avalanches of gas, rock, and ash, moving at speeds exceeding 150 kilometers per hour, cascaded down every flank of the mountain. They reached the sea. They boiled the ocean. The caldera that formed measured 6 kilometers across and over 1 kilometer deep. In a matter of hours, Tambora lost roughly 1,400 meters of its summit. The Volcanic Explosivity Index, the scale scientists use to measure the magnitude of eruptions, rates Tambora at a 7 out of 8. To place that in perspective, the 1883 eruption of Krakatoa, the one most people think of when they imagine the worst volcanic disaster in history, rated a 6. Mount St. Helens in 1980 rated a 5. Each increment on the scale represents a 10-fold increase in ejected material. Tambora expelled an estimated 160 cubic kilometers of rock, ash, and debris. It was not merely larger than Krakatoa. It was in an entirely different category of destruction. On Sumbawa itself, the consequences were immediate and absolute. The kingdoms of Tambora and Sanggar were obliterated. An estimated 10,000 people died directly from the eruption, from pyroclastic flows, from falling debris, from the tsunamis generated when displaced material crashed into the sea. But the dying did not stop there. In the weeks and months that followed, an additional 70,000 or more people across Sumbawa and the neighboring island of Lombok perished from starvation and disease, as crops were buried under meters of ash and fresh water sources were poisoned. The languages spoken by the people of Tambora vanished. An entire culture was erased in a single geological moment. Yet the most consequential chapter of Tambora's story was not written in Indonesia. It was written in the sky. The eruption injected an estimated 60 megatons of sulfur dioxide into the stratosphere. At those altitudes, sulfur dioxide reacts with water vapor to form sulfate aerosols, microscopic particles that act as a veil between the Earth and the Sun. These particles do not settle quickly. They are too high, too fine. Instead, stratospheric winds carried them around the entire globe, forming a thin but effective shield that reflected incoming solar radiation back into space. The planet began to cool. We follow the aerosol veil as it spreads westward across the Indian Ocean, over Africa, across the Atlantic, over Europe, and the Americas. By the autumn of 1815, brilliant, unusually vivid sunsets were being reported across Europe. The painter J.M.W. Turner, working in London, captured skies of deep orange and crimson that art historians would later attribute directly to Tambora's atmospheric debris. The sunsets were beautiful. What followed was not. The spring of 1816 arrived late across the Northern Hemisphere, and then it barely arrived at all. In April, cold rains lashed Western Europe without pause. In May, frost gripped farmlands from Ireland to Germany. By June, the catastrophe was undeniable. Snow fell across New England and eastern Canada. Quebec City recorded over 30 centimeters of snow in June. In England, the average summer temperature dropped by roughly 2 to 3 degrees Celsius, a seemingly small number that carried enormous agricultural consequences. Grain crops failed across the British Isles. In France, the wheat harvest was devastated. In Germany, food prices soared to levels not seen in a generation. Bread riots erupted in multiple cities. In Switzerland, the government declared a national emergency. We visit the fields of Ireland, where the potato crop, already the dietary foundation for millions, rotted in waterlogged, freezing soil. Families who had subsisted on the margins now faced outright starvation. The famine of 1816 and 1817, though often overshadowed in historical memory by the Great Famine of the 1840s, set in motion migration patterns that would reshape demographics for decades. Thousands of Irish families made the desperate calculation that leaving was the only alternative to dying. Ships bound for Canada and the United States carried passengers fleeing not political persecution, but weather that no one could explain. In southern and eastern Europe, the pattern repeated with regional variations. In Italy, red-tinted snow fell, colored by volcanic ash still suspended in the atmosphere. Witnesses described it as apocalyptic. In Hungary and the Balkans, persistent rains turned brown with particulate matter. Across the Northern Hemisphere, an estimated 100,000 additional deaths can be attributed to the climate disruption caused by Tambora, from famine, from disease outbreaks, fueled by malnutrition and displacement, from the sheer physiological stress of cold that would not relent. And yet, inside that suffering, something unexpected emerged. We traveled to Geneva, to the Villa Diodati, on the shores of Lake Geneva, in the summer of 1816. A group of young English writers had come to Switzerland expecting warmth, light, and leisure. Instead, they found endless rain, dark skies, and confinement. Among them were Lord Byron, Percy Bysshe Shelley, and Percy's future wife, 18-year-old Mary Wollstonecraft Godwin. Trapped indoors by the relentless weather, Byron proposed a challenge. Each of them would write a ghost story. Mary took the challenge and, over the following weeks, began crafting a tale about a scientist who creates life from dead matter, a story about ambition, consequence, and the boundaries of human knowledge. She called it Frankenstein. It would become one of the most influential novels in Western literature, the origin point of science fiction as a genre. And it was born, in part, because a volcano in Indonesia erased the summer. Byron, too, was productive in that gloomy confinement. He wrote Darkness, a poem imagining the extinction of the sun and the end of all life. Its opening line reads, "I had a dream, which was not all a dream." For Byron, as for everyone in that sunless summer, the boundary between nightmare and reality had become disturbingly thin. The disruption extended beyond culture and agriculture into medicine. In Bengal, The altered monsoon patterns triggered by Tambora's aerosol veil are believed by researchers to have contributed to conditions that gave rise to a new strain of cholera. The epidemic that began in 1817, the first cholera pandemic, spread from India across Southeast Asia, into the Middle East, and eventually to the shores of Europe. While the causal chain between Tambora and cholera remains a subject of ongoing scientific inquiry, the correlation is striking. The eruption disrupted global weather patterns. The disrupted weather altered water systems in South Asia, and from those altered water systems emerged a disease that would kill millions over the following decades. We examined tree ring data from across the Northern Hemisphere. Dendrochronologists, scientists who read the history of climate in the growth rings of ancient trees, have confirmed that 1816 produced some of the narrowest growth rings of the past 6 centuries in Europe and North America. The trees recorded what the farmers experienced, a year in which the sun did not provide enough warmth for life to fully express itself. Ice core samples from Greenland and Antarctica tell the same story from a different angle, showing a massive spike in sulfate deposits corresponding precisely to the Tambora eruption. The effects persisted. 1817 was not a full recovery. Harvests remained below normal across much of Europe. Food prices stayed elevated. Migration continued. The social and political instabilities triggered by 2 years of climate disruption contributed to unrest that would simmer for decades across the European continent. Some historians have drawn tentative but compelling lines between the suffering of 1816 and 1817 and the revolutionary movements that would eventually erupt across Europe in 1848. Hungry people remember who failed to feed them. By the early 1820s, the stratospheric aerosol veil had dissipated. Summers returned to their expected rhythms. Harvests recovered. The skies cleared. The world moved on and, remarkably, largely forgot. Tambora faded from Western consciousness. The year without a summer became a historical curiosity rather than a recognized global catastrophe. It would take nearly 2 centuries for scientists to fully reconstruct the connection between the eruption and the climate anomaly, to understand that a single geological event on a small island in Indonesia had measurably altered the temperature of the entire planet, disrupted food systems across multiple continents, influenced the birth of a literary masterpiece, accelerated migration patterns, and possibly catalyzed one of the deadliest pandemics of the 19th century. Today, Mount Tambora still stands on Sumbawa. Its caldera, vast and silent, fills slowly with rainwater. The forests have grown back on its slopes. Villages surround its base once more. It is monitored, but it is not feared with the urgency that its history demands. Somewhere in the stratosphere, the chemistry that Tambora exploited in 1815 remains unchanged. Sulfur dioxide still reacts with water vapor the same way. The sun can still be dimmed. The question that Tambora poses is not merely historical. It is a question about the present, about the fragility of systems we assume to be permanent. Climate, agriculture, supply chains, civilization itself. In 1815, one mountain demonstrated that the distance between a normal summer and no summer at all is not measured in degrees of latitude or political boundaries. It is measured in cubic kilometers of ash, in megatons of sulfur, in the thin and terrifyingly vulnerable layer of atmosphere that separates a living planet from a frozen one. The forces that shaped 1816 have not disappeared. They are merely sleeping. This narrative combines historical facts with dramatized elements. All visual reconstructions were generated by artificial intelligence.